In this video, we're looking at section 5.3. So this is a third way to solve systems of linear equations, and the process that we're going to use this time is elimination. So let's take a look at how we use elimination to solve a system of linear equations. Okay, so the learning target for this video, at the end of the video, you will be able to solve a system of linear equations using this elimination process. Okay, so the core concept is really this four-step process we have here for solving a system of linear equations using what we call elimination. And if you think of the word elimination, the root of the word to eliminate, so really what we're trying to do is we're going to eliminate a variable. So copy the four steps into your notes and we'll go over them. They're Step 1, we're going to multiply if necessary one or both equations by a constant, so at least one pair of like terms has the same or opposite coefficients. Then we're going to add or subtract the equations to eliminate one of the variables. We're going to solve the resulting equation for that variable, and then finally we'll substitute what we know about that variable into the original equation and we'll solve for the other variable. Okay, so we're taking a look at our first example to use this process for solving systems of linear equations using what we call elimination. So our first step is we're going to multiply through by a constant in order to have the opposite sign on one of the terms so that when we add them together, the terms cancel out. So this one's kind of already been set up for us. So if we are using the process for elimination, we're going to vertically add or subtract the two equations. So in this case, we're going to add them together. And we can see that if you have negative 2x and we add positive 2x, the x terms cancel out. And that's the whole idea of elimination. You want to set them up so that you have opposite coefficients on your variables so that one of the variables cancels out. And now we can solve just for this y. So when we add 3y minus y, or 3y minus 1y, we get 2y. And again, just vertically, we're adding here. So 4 plus a negative 8, or 4 minus 8, gives us negative 4. Okay? Keep solving for the variable. So we end up with y equals negative 2. Okay, so now we can take this y equals negative 2 and we're going to do the last step, which is substitute back into one of the equations. I'm going to substitute it into this one because this one has a coefficient of negative 1. So I've got 2x minus, and it's going to be minus y. We know y is a negative 2, and this is equal to negative 8. So simplifying, I have 2x plus 2 equals negative 8. Subtract 2 on both sides. So 2x is equal to negative 10. Divide both sides by 2. You can see that x is equal to negative 5. So the point of intersection where these two lines are going to meet is at an x value of negative 5 and a y value of negative 2. So this is the solution to this system of linear equations. Okay, so let's take a look at our second example. We're solving a system of linear equations using the process of elimination again. So here's our system of linear equations. We have an equation here and an equation here. We can see that this setup is not like the previous problem. If we were to add these two together, one of the variables will not cancel out, okay? And I also should point out that both of these equations are in standard form. So we have our x term, we have our y terms, we have equal sign, and then the constant. So if your equations are not in standard form, that really is the first step, like your setup step that you need to do before you even try to find a variable that's going to cancel out. Okay, so put them in standard form. And as we see here, if we try to add these two equations together, the x will not fall away, nor will the y. So 3x minus 6x gives us a negative 3x. 2y minus 5y gives us negative 3y. So we need to multiply one of these equations through by some value that will make one of the variables go away. So take a minute and think, which equation would you multiply through by what constant? And one of the ways, there's a couple of ways you could do this, but one of the ways would be to take the first equation and multiply it through by 2. So we're going to multiply by 2 on the left and the right. The reason why is when we multiply 2 times 3x, we get a positive 6x, which is the opposite of negative 6x. So our x variable will cancel. So the first step over here, I'm going to rewrite this equation as I multiply 2, as I distribute 2 to the entire equation. So when I distribute 2, I have 6x plus 4y equals negative 4. The second equation, I'm just going to copy it exactly as it is. So it's negative 6x minus 5y equals 2. And then adding these two together, we can see 6x minus 6x is 0. 4y plus a negative 5y gives us negative y. And then negative 4 plus 2 gives us negative 2. Dividing through by negative 1, we get positive y equals a 2. Okay, so that's our y coordinate. All right, so to find the x, now we're going to take and substitute this value in to one of our equations to solve for x. So we're going to substitute back in here. So let me use this second equation. So I have negative 6x minus 5 times y, and we know y is 2, and this is equal to 2. So we were solving for x. So this is a negative 10, and this is equal to 2. We're adding 10 on both sides. Make sure you're showing every single step. And we get negative 6x equals 12. Dividing both sides by negative 6, we can see that x is equal to negative 2. So if we think of the ordered pair where these two lines are going to intersect, it's going to be at a negative 2, 2. So this is our solution to our system of linear equations.